Hi, my name is Kathy Medina de Villiers, and I hail from Alexandria, Virginia, and I've been teaching computer science for about 22 years. So, welcome to the internet. Okay, what will we learn today? Okay, so we're going to look at how computing devices work together in a network. We have some essential knowledge here. Anything from the computing devices, we're going to look at physical devices, that physical aspects of a computing device so we can communicate on the internet. We're going to talk about paths and routing and the bandwidth. So let's start with a little bit of history. When we first start off with computers, they were big. They were really big. I have a picture of one here with the tape, not back to the ENIAC or vacuum tubes, but back in the day, not to date myself, but around 1975, we still had big computers. And people realized that working with just a big computer in isolation wasn't cutting it. So they had the idea of the internet way back. So you'll hear maybe something historically about ARPANET, one of the first nets that we had. But let's look at the evolution. So we started with these lovely big computers and they got smaller and smaller and smaller. And if you look, we had the computers like with the nice, lovely lime green font. That was our first PCs that came out. And we also have computing devices like sensors for our smart homes. And let's not forget our routers. They are actually computing devices and they really help push things along. So again, we had these computers and it's really stunk, working alone. You want to be able to like talk to your friends and computers want to be able to change data without actually having to constantly use a secondary memory like a floppy disk or a jump drive to go back and forth. Computers, they needed to talk to each other. Their users wanted to talk to each other. So it came down to the fundamental question, how do we get computers to talk to each other? Well, computers actually don't talk. So let's kind of work through that. Computers understand electricity, they understand electrons. Okay. And our electrons are represented by number systems. So if you want to say computers talk numbers to kind of say they talk, that's fine. That's what they understand. So we have to take all this information that we want to send. We have to like chop it down to these lovely little ones and zeros. And we just can't send it all at once. We have to like put it in a packet. So when you think about a packet, excuse me, we think about a packet, think about like a jigsaw puzzle. And you're going to put a piece of the jigsaw puzzle in this little envelope and send it like a postal system. And you're going to have a sender and you're going to have a receiver. So a packet includes the source and the destination of where it wants to go. So how do we get these computers to communicate? Yeah, we could put them in packets, but how do we get the packets to the computer? So we started forming together computer systems, a group of computers working together for a common purpose. And then, so we got these systems, computer systems, but we needed to create a network. And the difference is that now we have computers able to send and receive data. So let's look at some examples here. Let's talk about packet switching. So we want to send a packet. Okay. So what computers do, or what we do in a network system here, is that we'll take a packet or a bit of information, like the phrase, hello, how are you? And we chop it up into little pieces, like you can see in the picture below. And we put those little pieces in a packet, and then we send them along a path. Well, not all the paths are the same. And if you notice, they don't have to be in order. Like on the first path, I got the word hello, period. The second path, I have the end of the phrase here, you with the question mark. And down in the third path, oh, and we hit a router, by the way, we've got the words, how are you? And it's interesting because this router actually helps with what we call packet switching. It takes that packet, it's like, oh, where are you going? And it kind of guides it along the route that it needs to take to get to its receiver. So, kind of touched on it. The path is the path that the message will take between two computing devices, and the router is helps find the path. It's like over here. So, but we talked about path and routing. But let's talk about getting on that path and what it looks like. And sometimes that path gets pretty inundated. Actually, we call this bandwidth, the speed in which the packet and the information will flow. And we measure this by bits per second. And if you can think about rush hour traffic and getting on the highway, the more information that gets on the highway or the avenue in which the information is flowing on the path, the slower it might become. So bandwidth actually becomes kind of important here when we're looking at sending and receiving data. So let's go ahead and recap here. Why do computers need to communicate? Well, they need to communicate because together is better. Let's face it. You want to talk to your friend, it makes things a little bit more efficient. Hey, why have a cell phone if you can't text anyone? Let's think about it that way. But no, seriously, it's to that we connect to go ahead and transmit and data to make things a little bit easier. We use packets to transmit this data. Remember, it's like that jigsaw puzzle. We're taking a piece of that data and we're kind of throwing it in an envelope and sending it all in because we can't take it and move it through the internet all at once. Okay, so let's look at the vocabulary here. So I want you to take a moment and I want you to be able to match up your vocabulary with the proper description or definition. So if you can put your computer on pause, and when you're done, join back with me. Well, welcome back. And I am hoping you got 100. I'm sure you got 100 here. So let's look at path. Path is a sequence, okay? Remember the word directly connected computing devices, okay? And it begins with the sender and it ends with the receiver. You're going to send somebody, you want somebody to receive it. And a route actually goes ahead and helps facilitate that path. It kind of helps find the path. Remember, finding directions of where it needs to go. And we'll talk more about that later when we get into routers. B, when we look at a computer system is a group of computing devices that are working together for a common purpose. Now, remember, computing device is just not a laptop. It can be something like a smart sensor or a router, which we talk about a lot here. And then we have our bandwidth. It's the maximum amount of data that we can transmit in a fixed amount of time, and we usually do it bits per second. And then we have a computer network. And let's remember, computer network, what distinguishes a computer network is that it's not only just connected devices, but devices that can send and receive data. Okay. So what should you take away? How computer devices work together on a network. Looking at physical devices like a laptop, a cell phone, your smart devices like your sensors, looking at what a computer network is and the paths that they take and how routing or routers help to form that path so we can get from sender to receiver. And when we jump on the highway of information, let's not forget about bandwidth, okay, measured by bits per second. So I want to thank you for your time. I've really enjoyed being able to explain the internet to you, and I hope to see you on our next video on the internet. This is Mrs. Medina de Villiers. See you later.